the paper that he actually got accepted in the quote unquote best journal was total bullshit that he just made up. Hello, I am John Beckman, Professor John Beckman, Dr. John Beckman. Coming to you live from Southern Command with half my brain technically, just to make it fair. First, a word from our sponsors. A lot of people are wondering how Vice President J.D. Vance gets that chiseled jawline. Jazzerciser, fitness for your face. I'm working on mine. See if I can get mine close to that Giga Chad jaw. All right, I am John Beckman, Professor John Beckman. You can follow me on X at Stampede Press. You can also follow me on Rumble and YouTube at Professor Beckman. I would encourage you not to follow me. I'm a bad influence. Okay, so today is Technical Discussions 027, Secrets of Peer Review. So I'm just going to give an outline of my experience of peer review. I'm a tenured associate professor. I've published quite a bit of papers in the best journals and in mediocre journals and in what you would consider low impact journals, maybe a few dubious journals. So I've published quite a bit of papers in a bunch of different things. Definitely not the best publisher, definitely not the most cited, definitely not the best scientist, but hey, I get the job done. I'm still alive. Before we go into this, if you want the short of it, the too long didn't read. Peer review is total bullshit. It's all BS. And the key example, if you just want one quick example to just sort of take home the point, Kary Mullis, the Nobel Prize winner who invented polymerase chain reaction, so probably one of the most prestigious, most well-accoladed, decorated molecular biologists on planet Earth who have ever existed, who invented one of the most important procedures in biochemistry and molecular biology that completely changed the field. He wrote about this in his autobiography. He tried to publish his paper on this paradigm-changing technique in one of the top-tier journals, and the top-tier journals would not take it. They would not take it. They would not publish it. So he ended up publishing one of the most impactful scientific publications in what you might consider a very, very low, like low-tier niche journal. I would say I would not say not respected, but I would say it's a very low-tier journal. I think it's Methods and Enzymatics. That's actually the journal that has Kary Mullis's most world-renowned paper. And the interesting thing is that Kary Mullis actually does have a very prestigious quote-unquote publication in Nature and in his autobiography. So Nature's like the top journal, the best journal. And what Kary Mullis writes in his autobiography is that the paper that he actually got accepted in the quote-unquote best journal was total bullshit that he just made up. And the paper that was the most impactful, that was the real deal, the real thing, he couldn't even get them to look at it. And he had to publish it in Methods and Enzymatics. So that just gives you the readout of like peer review, total bullshit. All the journals, all the scientific journals are total bullshit. Okay. And I'm going to go through, I guess that's what this talk will be about, is all the conflicts of interest, all the scams, all the total BS that we have to deal with as professors trying to publish our papers. And part of it is our fault because scientists are total idiots and they just buy into this retard system. So part of it is our fault. And if we would just take charge of our own fields, like we could change it for the better. But we don't do that because most scientists are cowards. Okay, so to start off this, let me just outline some basics of journals. So a scientific journal is a publication that when you're a scientist, you do research, you write up that research, and then you submit it to a scientific journal. You publish your papers in scientific journals. Okay. There's different tiers of scientific journals. So there's kind of like what are considered like top tier journals. This is like Science, Nature, Cell. These are the most quote unquote prestigious journals. And then there's sort of like middle tier journals, which are sort of like intermediate impact, well respected, but maybe what you're publishing in there is not thought to be like earth shattering. The top tier journals supposedly publish like the earth shattering stuff. Okay. Mid-tier journals publish like high quality science that maybe not is earth shattering. And then there's what are called like low tier, which are not necessarily low quality, but they're more niche journals. So for like me, I do research on insects. And so if I have a very good research article that is on some particular insect that nobody else is going to care about, but it's still a great like science, you might go to like a niche journal. So something like this would be like insect biochemistry and molecular biology would be like a niche journal that's well respected in my field that I could publish in, or Journal of Biochemistry, something like that. These are lower tier, not necessarily lower quality, but just niche in a sense that most people are probably not going to be interested in this research. So what the top tier journals claim is that they're publishing the stuff that most people are interested in is like the claim. And already right there, like you could start to hint like, well, what are most people going to be interested in? Most people are going to be interested in total bullshit. So it's often that the real stuff doesn't get published in the high impact journals. Okay, and the way that the tiers of the journal systems are ranked is they're judged by citation count and impact factor. So automatically, obviously, if you publish in one of these like name brand journals, you're going to get a ton of citations because people like to cite those because they think that they're well respected. So that drives up their what's called their impact factor. The impact factor is a quantitative measurement of what's supposed to be like the quality of the journal based on how many citations it gets. Some people think this is total bullshit because, again, the best paper doesn't always get the most citations. It's often that the thing with the most citations is total bullshit. So there you can already see like an inherent problem in how they're like ranking the journals here. But understand that there is this sort of like tiered system of respectability of the journals. Okay, so now let's go into talk some about the scams of journals and all the conflicts of interest that are in this process. Okay, so this first point, most journals are for-profit entities that manipulate scientists because scientists are very stupid. So the bizarre thing is these journals that we as scientists publish papers in, there's some crazy shit that maybe you don't know about. So I have, as a scientist, I have to pay the journal to publish my article. So even though I did all the work and it should be their honor to sort of like publish this great new achievement, I actually have to pay them. And publication costs of publishing a paper range between $2,000 to like $5,000, maybe even $7,000 in some of the high tier journals. So one is I have to pay them to publish my article. Maybe people aren't aware of that. So they're a for-profit entity. The other thing that's totally bizarre is they don't do all the work. I'm the one who writes the paper. I'm the one who prepares the figures. I'm the one who does the editing. The only thing that the journal does is send out emails to coordinate other professors to do peer reviews. So they just do a little coordination. And I have to pay them $2,000 to $5,000 to $7,000 for that process for every single article that gets published. So they only care about making money. They don't care about the science. Their interest is not in publishing good science. Their interest is in making money and paying their staffers. And scientists are so stupid because, again, like, why? It's the scientists who are peer reviewing. So in theory, like they're sending out and they're getting other professors to peer review some article. But we do that for free. We don't get any benefit from that. Literally, they're like, there's no benefit to me spending hours and hours a day to peer review a paper. So they have built this bizarre slave labor system where they coerce professors to review other people's papers for no benefit. And I don't know why we do this. It's retarded. So I guess first thing is just to understand that the journals do not have the same interests as the scientists. These are two separate interests, and the journal is not representing the interests of science or scientists. They're just trying to make money. And they often paywall the papers. So even though I paid thousands of dollars to publish my article, most people can't even read it. To actually make it open source where people can actually read the article, I have to pay an extra $2,000 to make it open source. So sometimes a paper might cost something like $5,000 to $10,000 to make it accessible to other people. Again, like why do I do this? Why don't I just put my paper out on the internet? 3, there are what are called scam journals. Okay, so because this is like a for-profit entity, there are journals that essentially are mass marketing schemes. Well, they'll send out mass marketing emails, hey, to professors. So they collect email lists of professors, and then they send out mass marketing emails, hey, publish your paper in our journal. And essentially the deal is you submit your paper and they'll put you through very unrigorous peer review, and you just pay them to publish your journal. That's what's called a scam journal. So a scam journal is just set up as a scheme to make money. And professors, I mean, I don't, again, like, why would you publish in these journals? You don't want to publish in these journals because it's going to be disrespected. But one reason you might publish in these journals is because publisher pairs. So professors are held under the standard that we need to publish a certain like amount, a numerical count of papers per year. And maybe if you're not hitting your number per year, maybe then the scam journals become a little bit more tempting. I don't care about this shit. Like I again, like I'm not trying to boost my numbers. I don't give a shit about my numbers. So I guess maybe that's one reason why these are less tempting to me. But there are actually people who submit to what are blatant frauds, and they do it so that their paper can get through without any rigorous peer review. So essentially the scam journals, they will not review the science properly. So if you understand this, you can understand that, again, 50% of all publications, 50 to 90%, I kind of think it's more like 90%, are just total bullshit. And one part of this is because people can just submit to these scam journals that publish anything, as long as you pay them the right money. Okay, so let's talk now about bean counting now. Again, so here's like a conflict of interest that's caked into the scientific system. So, and this is caked in all throughout. Okay, there is what's called bean counting. Bean counting is sort of like the management style that plagues science. Okay, so when I go to have my year review as a professor, they bean count how many publications I've got. So they count how many publications you have. 1, 2, 3, 4, or 5, or 10. And if you get 10 publications, you are a stellar star. But they never look into like, well, what was the quality of those publications? What was discovered? Are those published in bullshit journals? Are those published, are what you publish just total bullshit? Nobody looks into that. So professors are ranked on bean counting. How many papers you just publish. So if a professor wants to cake their numbers, they can just publish a whole bunch of shitty articles. I could get anything published if I wanted to. If I could publish anything somewhere, okay? So bean counting is a huge problem. And it's not just at like institutions. It's not just at the universities. It's also for grants. So it's in the government. When you are applying for a grant to decide whether or not you are a qualified scientist to get that funding, part of it is they look at the counts of how many publications you have as a measure of productivity. So they will bean count professors and determine, like, are you spending the money wisely? Well, maybe you're not spending the money wisely if you have only published 3 papers per year. Maybe you should be publishing 5 papers a year, something like that. So they can use this as, again, a bean counting to try to assess the quality, but it's not really an assessment of quality. It's just assessment of quantity. So this selects for shitty publications. It's building a system that encourages shitty publications. And again, for me to get promoted, I actually have a numerical count of publications that I need to hit. So it selects for me trying to hit that or exceed that number of publications, which isn't always selecting for good science. That's often selecting for just crap. That's bean counting. Again, that goes into sort of like the quality versus quantity. That's a huge debate in science. That's a huge problem that plagues science. Other conflicts of interest. So if you are a graduate student or a master's student, PhD student, or a postdoc, in order to go to the next level, you have to publish papers. So again, there's another conflict of interest. If you want to rise up the chain, you have to hit the numbers. Okay, bean counting. I think so. If you look at like some of the best scientists, some of the people that I most respect are only publishing 2 papers a year. Okay, so when you look at people's Google Scholar, or you look at people and you try to assess like what's their productivity, and you will find people that have like 10,000 papers. Okay, ask yourself a question. Do you think that those people are actually writing those papers? Do you think that those people are even involved in that research in any capacity? No. What they've done is they've built what's called a factory lab where they're just at the top. Their job is to just bring in money. Okay. So they're just writing grants all the time, acquiring money. And then they've built a factory that just increases the number of publications that person at the top has. It's like a Ponzi scheme that's selecting for high quantity of publications. Okay. So any scientist who's publishing more than 2 publications a year, you should be very skeptical of that person's science. In my experience, it takes me years to build a scientific paper that I trust. I'm often publishing things that I've worked on for 5, 6, 7 years. The most recent paper that I just submitted, I had worked on for 7 fucking years. And I only just submitted it because it's only at the point where I trust the data. So even the best scientists can really only write and manufacture 2 good publications a year. Otherwise, it's just a distributed factory, and that person is no longer actually doing the work. It's just outsourced, and they just are sort of like owning the system. Okay, other conflicts of interest that sort of feed into the negativity of the system. Okay, there are what are called citation rings. So the whole like publishing system can be hacked by network effects. So if you have a great network, you are well liked in the field. You go talk to people at meetings all around the world. You network with people. You buy them dinners. You buy them lunches. People like you, etc. You will get people who will start citing you because they want to be sort of like your friend. They want to acquire the benefits of having your power influence them in a positive way. So then that builds what are called citation rings. So citation rings are essentially like networks of people that all like each other, that form like little cliques, that cite each other's papers, and that boosts everybody's numbers and boosts their impact. So what the point is this is a concrete example. Everybody knows this exists, and they're easy to detect. This is one example of how the system can be easily manipulated by a network. So again, another reason that peer review is bullshit, and what comes out in the papers just because it has high citations, that doesn't mean that it's good. It just means that it's being replicated like a meme by a network of people who like each other. There's also conflicts of interest in actual like the process of citation. Okay, so one of the things that you're trained on as a scientist when you write grants, one of the things you're trained on is you better cite the right people, because if you piss off the wrong person, they're not going to fund your grant. So you better cite the people who are on that grant panel, and you better cite their papers. It doesn't matter whether their science is good or bad. You fucking cite them, because if you don't cite them, you'll piss them off, and then they won't fund your grant. So there's a huge conflict of interest in that. You might actually, when people cite things, they might not actually even be citing you for the right reason. They're just citing you to, again, bolster that person's numbers and build a network. Another conflict of interest is that reviewers can force you to cite other papers. So if I submit a paper for peer review and I've written it in one way because I have collected the data and the data leads me to these conclusions, and so blah, 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 I'm writing this paper and I wrote it and it's what I actually think. The reviewers can read your paper and they can say, we will not allow this paper to be published unless you cite XYZ papers. So people who are in the review process can force you to cite other papers, whether or not you even agree with that science. You might completely disagree with that science, but in order to get your paper published, you still have to cite them because the reviewers said you must cite this paper in order to get this paper published. So you can see how this can then build a propagation network that propagates false science because you're forced to cite people's papers under the conditions of a certain peer reviewer to get your paper published. 7. Okay, so these high tier journals, these are essentially like a gatekeeper system into the network. So if you get a publication in one of these high tier journals, you've essentially been accepted into the gatekeeping network. And then those journals invite you to be a reviewer. So they're sort of like propagating their network. And oftentimes, if you have a paper that's paradigm changing and you try to submit that to a high tier journal, that paradigm changing paper is essentially going to be saying that this whole field is based on lies, based on total bullshit. You think that the people whose careers that would damage are going to let you publish that paper? No, they're going to fucking gatekeep you, and they're going to not allow you to publish your paper in the most prestigious journal because it would embarrass them. And that's what happens. 8, it's not clear to me even what function the journals serve anymore. So I write the papers, I edit the papers, I prepare the figures, my students prepare the figures, we edit the papers. I can publish all the shit online for free. So it's not even clear to me like why I publish papers in a peer-reviewed system. If I want peer review, I could actually recruit some of my people that I respect to look at my papers and give me thoughtful comments. And it's often that I get more thoughtful comments and more rigorous peer reviews from people who I respect, who I trust. Those people give me better reviews than the peer reviews that I get when I submit into the system. 9. So here's a real bizarre thing. I don't understand why we as scientists don't fight against this. We're not allowed to what's called cross-submit. So when you submit to your paper to a scientific journal, you have to click a box that says, I'm not submitting this anywhere else. I'm only submitting it to your special journal. Why do we do that? Why do we do that as scientists? We are the ones that have the leverage because we are the ones who do the peer review and we are the ones who write the papers. We should be able to submit our paper everywhere we want to submit it all at the same time and make journals compete for it. Make journals compete for your best research. But for some reason, we can't do that. It's considered like unethical, which I don't understand because it's not unethical to me in any way to cross submit to other papers. It's my paper. So, I mean, I might break that rule in the future because I think it's total bullshit. It's another way that the for-profit journals manipulate the system so that they don't have to compete with other journals. Listing suggested reviewers. Okay, so here's something you can do when you submit a paper. When you submit a paper, you usually write what's called a cover letter. On the cover letter, you describe what the research is, you describe the advancements, and then you can say, I would like these people to review it. The positive side of this is that if you're picking people who you think are qualified to review the paper, that could be helpful. That could be helpful to the journal. So that's not totally bad. But on the bad side of this, what some people will do is they'll list people who they're friends with, but they've never collaborated with. So legally, those people can review their paper. And so people establish these lists of, here's people that I've never collaborated with, but are my friends, and my friends can review my paper. And you can see how that could corrupt the system, even though I literally just said that maybe my friends give me the better reviews. But you can see how that could create negative influence. 11, anonymous peer review versus signed peer review. So here's another debate within like the academic scientific community. Anonymous peer review means that an anonymous professor writes a peer review and doesn't sign their name. So it's essentially the argument for anonymous peer review is that if you're a younger professor in the field and you don't want to be quote unquote punished for giving a bad review, you don't have to sign it. Okay. That's the positive side of it. The negative side of it is that if you're a well-established gatekeeper, you can write a killing review to destroy somebody's career and you don't have to sign it. Okay. So that's fucked up. Like, I don't know how to fix that, but that's fucked up. So when I first started, I always felt like, man, I'm going to sign these reviews. I don't know what I feel about this anymore. I'm just like so cynical. And so I feel the system is just so fucking broken. Like, I don't know what to think. When I first started, I was very naive and I thought like, I'm going to sign my reviews just because like, I feel like ethically, you feel like if you're going to write something, you should sign your name on it. If you're going to say something negative, you should be able to stand that person to their face and say it to their face. So I often will sign many of my reviews, but then I've gotten to situations where it's like, I don't know. Well, it's like, yeah, you're like, I don't know if I want to piss this guy off. So you can see like, again, like there's conflicts of interest all ethically throughout this. And I don't know how you make the best decision on that. But as a reviewer, it's your right whether you want to sign it or stay anonymous. And that creates problems. And maybe it's a wash. I don't know. So there were some journals that try to sort of like help the process. So there's a journal called eLIFE, which I've published in. eLIFE is supposed to be sort of like trying to fix some of these problems. So one of the things that they developed is they publish the peer reviews. So when you publish the paper, they will also publish the peer reviews. This at least provides some accountability to the anonymous reviewers, where the anonymous reviewers can't write wacky shit that's tanking a paper because it's going to be published with the paper. And I think that's a good model. So this helps to fix peer review a little bit, is that the peer reviews come out with the paper. And so you get to see what actually people like said about it. I think that helps to keep people a little bit honest. I don't think that the top tier journals are doing that, which suggests there's a lot of skanky business going on that's not being published in the review. And again, as a reviewer, I'm a smart guy and we're dealing with smart people all the time. Professors are smart and professors are fucking mean. I could tank a paper if I wanted to tank it. And anybody else in their field knows that they could fucking tank a paper for bullshit if they wanted to. And so it happens all the time. Okay. So those are like a list of some of the conflicts of interest in peer review. Let's talk about the actual peer review process. So you submit a paper. The first thing that happens is the editor at the journal decides whether or not they're going to review your paper. So your paper can be rejected out front without them even reading your paper. So here's a bizarre thing that people don't understand. Again, people think like you submit a paper to a scientific journal, it'll get reviewed. No. Okay. You submit your paper and the editor first makes a decision on whether it's going to like essentially be profitable. So you can be what's called editorially rejected, which means they've rejected your paper, but not based on any science, not based on any criticisms, not based on anything other than the editor doesn't want to publish your paper. That's called an editorial rejection. Okay. And that happens 90% of the time. Most of the time when I submit a scientific paper, it doesn't even get to peer review. It gets editorially rejected. Here's the funny thing about editors. And here's another thing that the public doesn't understand about the scientific system is that most of the editors are considered the flunkies, the idiots, the retards who dropped out of science. They were not able to make it in science. And so they left science and became editors at journals. So the joke amongst professors is that we are getting our papers editorially rejected by people who couldn't even hack it in the actual scientific system. That's the joke. Okay. And again, it's like, why do we submit to these people? Why aren't we organizing our own peer review, our own journals? Why are we letting idiots editorially reject our papers? I don't know. We're stupid. So if the reviewer, you submit your paper, if the editor decides this paper might be worthy, then sometimes what they do is they usually secretly solicit like input. So sometimes what they'll do is they'll get consultation by what are called expert reviewers. I don't know who these people are, but they never tell you. They never tell you who these people are. Okay. So they'll get consultation essentially on whether your paper should be reviewed or not. So again, there's like, does the editor think your paper should be reviewed? Do the secret reviewers think that your paper should be reviewed? And then finally, if you get past that stage, it goes to the stage of, okay, now we're going to actually do actual peer review. Okay, so imagine your paper gets to actual peer review. Here's some huge problems and more conflicts of interest in this entire process. Guess who is most qualified in theory to review your paper? It's your enemies and your competitors. The people who hate your research are often the most quote unquote qualified to review your research. Okay, so in my entire career, every single time I submit a paper, it's my enemies who are reviewing my paper. You think that they are unbiased? No. I mean, again, when I say if you want to kill a paper as a professor, it's very easy to do. And so if you're an enemy, think about the conflicts of interest here. You're competing with somebody who's studying the same idea as you. You're competing with them for money. And it's not small amounts of money. It's millions of dollars of money to fund your research. You think you're going to give them a good review? Okay. That's the problem of the system. It's rampant with conflicts of interest. And that's happened to me my whole career, where you submit a paper and people can shit on it because it's the same people who are competing for the same money pot that you're competing for. So review happens by your enemies and your competitors. This is why people build networks of friends to help them. Otherwise, you can't get anything published. Okay, preprints. We'll talk more about peer review down. Preprints are the concept that if you're going to submit a paper, oftentimes peer review takes years. Peer review can take multiple years. I've had a paper that took almost 2 years of peer review to get published. It was horrible. It was a nightmare. Preprints are the idea that you can put out your paper on like a preprint server so that people can read it. And before it's quote unquote peer reviewed or before it's quote unquote published in a rigorous scientific journal. I don't know whether this is helpful or hurtful. I've had situations where I think it's helped me to put out a preprint, and I've had situations where I think it's hurtful to put out a preprint. It can be hurtful in the sense of if you actually do have a paper that's kind of like, wow, this might be actually like a splash. I think it's hurtful to put out a preprint because it helps, or it removes the sort of effect of like, well, here's the splash. On the other hand, it gives the professors leverage against the corrupt journals. So if the corrupt journals are saying like, we're not going to publish this because we don't like what it's saying, or if they're editorially constantly rejecting your paper, you can put it out as a preprint so that other people in the field can see it. And again, like people know who I am, whether you respect me or not, like I don't care, that's up to you, but I can put out my stuff so that the people who do respect me and respect my work can see my work so that it doesn't get essentially shadow banned for decades. So preprints are helpful in that sense, but they're also hurtful in the sense that it's kind of like removing the big splash. The other negative thing about preprints is often people will inundate the preprint servers with garbage. So again, a preprint is a good way where like, if you don't have a paper that is not rigorous, or if you have a paper that's not rigorous, sometimes people will put that out on the preprint server, and that then manipulates the discussion in the field with unsubstantiated claims. So there's pros and cons to preprints. I don't know whether they're helpful or hurtful. I haven't made a decision on that. I think there are some cases where they've been helpful to me and some cases where they've been hurtful to me. I like having the option there in case there's some shady business. And I have had experiences where I've had shady business happening under review under some of my articles, and I put it out as a preprint. And then that built up the leverage where I was finally able to leverage and say, look how much interest this thing is getting. You better can peer review it. And that helped me get one of my papers published. Okay, again, we'll talk more again about peer review here at the end. Other things just about research. So like things that you should know about science and about the scientific system. So there's what's called basic research versus applied research. Okay. Basic research is sort of like the idea that there are many things that we don't know about the universe. We don't know about biology. We don't know about physics. There's many things that we don't know. And we don't know what the application is, but we should study these things because they're interesting. And it's often that sometimes if you just study things that are interesting, sometimes you get extreme benefits. So for example, when the CRISPR systems were first studied, those were just bacterial immunity systems. They were not gene editing tools. They were studied as systems that fight off viruses in bacteria. And so there wasn't as an applied aspect to the CRISPR research in early days, okay? Another example of this is GFP. So GFP is a protein that glows green. And GFP has become like a tool that has drastically helped molecular biologists and science. And the person who studied that won the Nobel Prize. And he only studied that because he was interested in jellyfish and he was interested in answering the question of why do they glow green? And you could imagine that somebody studying that, what's called basic research, might be pulled in front of Congress and they might be brought up and they might be questioned and said, well, why are you studying this? This is so fucking stupid to try to understand why jellyfish glow green. And his answer would probably be something like, I don't know why I'm studying it, because it's fucking interesting. That's why I'm studying it. And nobody can argue with that because sometimes those discoveries happen to change the world. So again, that's basic research. You're just studying something because it's interesting. Applied research is where you're actually trying to study a problem, or you're trying to fix a very specific problem. So understand that there's sort of like a dichotomy of research. And both of these things need to be funded, because if you only fund applied research, you will never get the basic research advances. Okay. So it's important to understand that both of these things are valuable. You cannot just only fund applied research. And I kind of have a mix of both. Like I have some things that I just study for basic research, and I have some things that I just study for applied research. Some things are just very interesting to me, and other things are I'm trying to actually like solve a problem. You have to fund both, is what I think. Okay, why fund basic research? So this is a question that I've actually seen. So again, on some of the people that I really respect, I follow their podcasts, I've actually seen this question come up where they say, we should really only be funding applied research. Let me try to like address that, that question. So I've also studied a lot in biotech and sort of, I've had a lot of sort of interaction with the VC venture capital community. I've never been successful there, so like don't trust anything I say, but I had a lot of interaction with the VC community. And one of the things that they say is that there's sort of like a gap in research where if you're researching any particular topic, there is a point in time. So if this axis is time, the timeline of research on some topic, okay, there's a point at which early on, it's just basic research. And when people are trying to understand the system, there's no way to make profit from that system because you're trying to learn about how it works. You're trying to understand the system and you don't know enough about it yet to be able to turn it into a product. And oftentimes we do lots of basic research on topics, and the basic research funding sort of like wanes. And there's sort of like a danger zone where the things that you're researching go through like a death phase. Most research topics sort of like die out, where they go out of phase, they are not funded anymore, and only a tiny amount of essentially research projects end up in the VC phase where they actually get funded again and become a useful product. And there's actually like a name for this danger zone. I can't remember what the actual name is. Somebody should look it up. But this is why you need to fund basic research, is because you don't actually end up with novel, useful products if you don't actually fund the basic research. You have to fund this phase, and you have to understand that 9 out of 10 things that you fund are going to be useless. 90% of the research funds are going to be wasted on shit that doesn't become useful. But you have to do it because you don't understand which of the things are going to be useful in the long run. You cannot predict. That's the problem. So that's why you have to fund basic research to get through the VC hump, to get to the point at which something becomes useful to the venture capital community. Okay. There's also different things of what people publish in science. So the sort of like gold standard is what's called hypothesis-driven science. This is what you learned about when you're a kid in high school or in elementary school. You think about a question, you wonder how something works. You develop a hypothesis, you collect data, you test the hypothesis. You analyze the data. You figure out, do you think that you make conclusions? Were you correct? Was your hypothesis correct or not? And then you adjust your hypothesis. That's what's called hypothesis-driven science. That's actually very hard to do. And most publications are actually not doing that. This is probably a problem that people don't even understand. Most things that people do are what are called data dumps or observational science. So again, this is the idea that like I could publish anything. People publish trash all the time. Data dumps and observational science are often just garbage that people publish. So for example, if I want to get a paper, maybe I just publish observations about something. That's observational science. Or maybe I just do like a sequence a genome or do a transcriptome, which is figuring out all the different transcripts that are made in a particular cell at a particular point in time, and then publish a transcriptome. That's one example of what's called a data dump, where you're not even asking the question. You're not even forming a hypothesis. You're just collecting data and you're publishing, hey, look at my data. Here's a bunch of bullshit data. That's often what people do. And so many publications are just bullshit data dumps where people are just publishing a bunch of observations with no meaning, no real analysis, no question asking, because hypothesis-driven science is extremely difficult to actually do. And probably 50% of everything that's been published is probably not even hypothesis-driven science. They're not actually even testing hypotheses. People don't even realize that. Another thing that people publish, okay, and this is different. People don't understand. Again, people say, I hate all these comments about how trust the science. What is science? Okay, there's many different fields of science, and there are some what are called hard sciences and some what are called soft sciences. Soft sciences are essentially have the stereotype that you can publish anything. You can publish garbage. You can publish shit. The p-values are high. Okay, I won't call people out, but there are what are known as soft sciences, and then there are what are known as hard sciences, which are you do the work, you do a hypothesis, you test the hypothesis, you figure out whether you're right or wrong. And then you only publish when you know like it's correct. And it will only get published if people believe that it's somewhat correct and it's reproducible. Okay. So that's hard science versus soft science. Both of these are everywhere. Another thing that contributes, people have fights about this. And there's philosophical debates on either side. So there's what's called negative data and positive data. Negative data, so it's the concept of negative data is the idea that you ask a question and you get an answer of, I don't know, or we don't know, or the answer, or maybe you get a no answer. The problem with negative data is you never know if the person doing the experiment is doing the experiment correctly, okay? So a lot of what philosophers think is useful is they think philosophers tend to think that negative data is very useful because they think it's very important to sort of like disprove things. Well, this can't be true. This can't be true. This can't be true. The problem of actually, like, it sounds like a good idea. And I hear that. I understand that. I think Karl Popper, I'm not a philosophy expert, but I think that Karl Popper sort of like likes this idea. We should be like disproving a bunch of things. Here's a problem with that, with actual science. The problem with that is the people who get negative data are often incompetent. So they don't understand that 90% of scientists are incompetent. And how can you trust negative data? How can you trust that the person just didn't do the experiment wrong? Just couldn't actually have the hands, the giftedness of the hands to do the experiment correctly. Okay, I'm telling you that there is genius and there is talent in science. And most scientists do not have the talent. So I don't trust negative data because it's kind of like, it's a no answer. But why is it a no? Is it a no because they actually did everything correctly? And the real answer is no? Or is it a no because they did everything incorrectly? 90% of the time, it's because they did something wrong and they don't know what they did wrong. So they think the answer is no, but the answer is actually yes. That's the problem with negative data. And soft sciences often allow you to publish lots of negative data. So again, imagine if you do an experiment, you do a test, and the answer is no. And many people in soft sciences are allowed to sort of publish the negative data. Oftentimes in hard sciences, you're not allowed to publish negative data because positive data is more valuable if it's real. Again, that's the conundrum. Like, is it real? I don't know. But positive data, if it's real, is the most valuable thing you can accomplish as a scientist. And so there are some scientists some sciences that only allow you to publish positive data where you have done a hypothesis, you tested the hypothesis, and now you got the correct answer to the hypothesis. That is positive data. That's much, much harder to achieve. And that's much, much, much rarer. Okay. And it's much more valuable because if something is positive, you know it's real. And if it's reproducible, you know it's real. Okay. So again, it's a debate. I tend to favor publishing positive data. I think that's what creates the most rigorous, constructive science, actually figuring something out. Okay, more about peer review. Why peer review cannot work. So this is point 23. It takes too long. So again, me as a reviewer, a journal contacts me to review a paper. If I was to really review a paper, it's going to take me a whole day. It's going to take 8 hours to review a paper intensely. I could probably review a paper half intensely for 4 hours, and I could probably review a paper skim-wise for 2 hours. Imagine what you're going to get knowing that professors are extremely busy, they're paid pretty low. Like, what's the incentive to review a paper for 8 hours of the day? There is no incentive, okay? So most of the reviews that you get are very, very low quality. If you're lucky, somebody put 2 hours of work into reviewing the paper. Very, very rare to actually get a reviewer who spends 4 to 8 hours reviewing a paper, okay? It takes too long. It's too hard. So the system doesn't work because nobody's willing to invest that effort for free. 24. Often you might think, like, again, the public thinks we submit a paper, you hear that the standard is that there's going to be 3 reviewers, and 3 reviewers establishes some kind of like pattern. And if all the 3 reviewers agree, then it will get published. That's not what happens. Oftentimes in peer review, they can't even get 3 reviewers. Oftentimes they're publishing papers with 1 reviewer and the editor making a decision. Or if you're lucky, 2 reviewers and the editor makes a decision. Or if you're in a very prestigious journal, usually they can get 3 reviewers, okay? But my point is that most of the things that are published do not actually even have 3 peer reviews. Most of the things that are published probably have 1 to 2 peer reviews, and those 1 to 2 peer reviews are essentially like 2 hours of work if you're lucky. So peer review isn't even happening. Okay, now think about highlighting more conflicts of interest. Think about the motivations for why somebody would peer review a paper. Okay, again, me as a professor, I've got my own job. I don't make very much money. I'm very busy. I have to do lectures. I have to teach. I have to do my own research. I have to write my own papers. I have to write my own grants. I have to manage people. I have to have meetings with people. I have to do service, etc. All this crap. You think I have time to spend 8 hours to peer review a paper? So now think about, why would somebody actually do that? Why would somebody peer review somebody else's paper? Well, one, maybe you want to get the scoop on the enemy's research. Maybe you want to see, like, what is the enemy doing? So oftentimes, again, this funnels into the system of, well, who are you actually going to be attracting to do the peer reviews? It's your enemies. Your enemies are going to be reviewing your paper. B, maybe you want to gatekeep. Maybe you want to prevent people from destroying your reputation. So maybe the people who are reviewing your paper are actually only inclined to review your paper because they want to prevent you from being published so that they protect their own reputation. Maybe they want to help a friend. Maybe they know this person who wrote this paper, and maybe they're going to scratch their back so they can get their back scratched later. Or this is the benevolent answer that people think the journals suggest. The journal suggests that the reason you should peer review a paper is because you get to learn about the field. That's the positive thought. 13. Okay, again, other thoughts of why peer review cannot work. It's very hard to judge science. So if you're actually having a paradigm-changing paper that is changing the whole field, who do you think can judge that? The people cannot judge that, okay? And again, it's going to be destroying other people's careers if you actually have a paradigm-changing paper. So you cannot actually, it's very hard to judge science. Most of the papers that are extremely impactful get published in some shitty journal that nobody knows about. They sort of disappear for like 20 to 30 years. And then somebody reads it later when all the sort of conflicts have been removed from the field and rediscovers the science. And then finally it's discovered the value in what that person published. Many of the Nobel Prize winners are actually winning Nobel Prizes for work that they did 20 to 30 to 40 years ago, and the value is only just being seen now. So it's very hard to judge science because science is so slow. It often takes 50 to 100 years to look through all the patterns in a field, throw away all the shibboleths and all the bad insights, and be left with the core of what was real. That often takes 50 to 100 years. So it's very hard to judge science. 14, final reason, or one other reason why peer review can never work. It's very easy to manipulate with networks. Again, I talked about the network effects. It's very easy to manipulate peer review. And the other thing about that is actually publishing bad science is very detrimental to the field. If somebody publishes something that's wrong, that can set a field back for 30 to 50 years. It might take 50 years for that concept to be thrown out. And so somebody publishing a crappy paper can wreck an entire field. So this is all the reasons why I'm very jaded about peer review, very jaded about science. I don't even believe in science on some level. Like, the whole system is corrupt. The whole system is broken. Nothing works well. I like the idea that we like to research basic projects and we like to research things that are interesting. And I hope that people are publishing things that they think are correct. And I hope that people are not just putting out stuff to collect bean counts. But the reality is that most people are not like that. Okay, final things I'd like to talk about since we're talking about science. Science in the news. I do want to talk about these things that have come up. Shrimp on treadmills and the transgender research. I think there was like, let's construct transgender mice. Let me just talk about these from, again, a research perspective of a MAGA person who likes science. Let me just talk about these. Maybe you'll hear something you didn't quite hear. So shrimp on treadmills. That was brought up as sort of like, here's the example of wasteful research. So first of all, let me agree. There is a ton of wasteful research. All the DEI crap, all the environmental crap, there's just a ton of wasted research dollars. And oftentimes, as you learned in this paper, research is often just an agenda item to funnel money to the causes that you like. So oftentimes research is not even real, and there's a ton of waste in research. But again, as a biologist, as an entomologist, who very close to shrimp, let me try to posit this for you. Imagine you were a farmer in Louisiana, and you grew shrimp, and you wanted to figure out some way to measure the health of your shrimp. Okay, you could imagine knowing the health of cows is very important. Knowing the health of honeybees is very important. Being able to measure the health of humans is very important. How do you measure the health of humans? Oftentimes you put them on a treadmill and you measure their cardiovascular output, their biosigns, their biostatistics, whatever, on a treadmill. Now, again, think about the situation of the farmer. If you wanted to develop a method to assess and quantify the health of a shrimp, you might devise a treadmill to put the shrimp on the treadmill to figure out how healthy it is, how alpha it is. Okay. So that is just sort of like, I did not read the research. I don't know what the grant is. I don't know what they were doing. I don't know what experiments they're proposing. I don't care. I'm just saying that there is a rationale for why you might put a shrimp on a treadmill. Okay. If you want to assess shrimp health. Transgender research. Let's talk about that. Okay. I actually am very interested in the transgender research. So what people have discovered with insects is we've mapped out what's called the sex determination pathways of many insects. So we know sex determination pathways in fruit flies. We know sex determination pathways in mosquitoes. And essentially what we've learned is that there are individual genes that control whether or not an entity develops as a male or a female. Okay, so there are singular genes that cause something to develop male or female. Okay, now understanding sex determination is actually extremely important. There are many reasons in science, and I actually study one of them, which is called sterile insect technique. There's many reasons in science where we want to be able to kill or select for one particular sex. So we want to know, what is it that makes a female? What is it that makes a male? And we want to be able to manipulate that to essentially like eradicate one half of the population. That's actually like a legit thing that entomologists want to do. And there's many other reasons to want to know sex determination pathways. Okay. So what we've discovered is essentially like you can mutate sex determination genes to create a transgender. In mosquitoes, you can mutate a gene called Nix, which is an ortholog of transformer. The gene is actually called transformer. And if you mutate transformer, you produce trans mosquitoes, which are essentially chimerics that look half female and half male. Okay, so we can create transgender insects by mutating specific genes. That's what we've learned about transgenderism. So again, I don't know what this grant on transgender mice was doing. I don't know what it was researching. I don't know if it was like a trans propaganda thing or if it was studying sex determination in mice. Studying sex determination in mice might actually be very important because it would help us understand what is transgenderism. I think that transgenderism in reality is probably a mutation of sex determination genes, and they might have actually been studying it. So to be able to understand that transgenderism, much of it is made up, much of it is total bullshit, but there are actually mutations that can cause transgenders, and knowing what those are in mammals might actually be quite helpful. So those are two instances of sort of like the research that people are talking about that maybe you haven't heard about it talked in that way. Again, I don't know what the grants were. I don't care if they get funded or not. It's not my research. I don't care. But sometimes you got to be careful about these things because sometimes you do have to fund basic research. So just think about that. Have a good day.
I am Worf, son of Mo. I have much to teach you about women. Notice how the Klingon lures a mate. Klingons do not pursue relationships. They conquer that which they desire. Today, I am a warrior. I must show you my heart. I travel the river of blood. I am a Klingon. A demonstration can be arranged. I am a Klingon. A demonstration can be arranged. I am a Klingon. A demonstration can be arranged. I am a Klingon. A demonstration can be arranged. I am Worf, son of Mo. I have much to teach you about women. Notice how the Klingon lures a mate. Klingons do not pursue relationships. They conquer that which they desire. Today, I am a warrior. I must show you my heart. I travel the river of blood. I am a Klingon. A demonstration can be arranged. I am a Klingon. A demonstration can be arranged. I am a Klingon. A demonstration can be arranged. I am a Klingon. A demonstration can be arranged. Birds' females are too fragile. It is a good day to die. It is a good day to die. It is a good day to die. Today, I'm a warrior. I must show you my heart. I travel the river of